Welcome back. This module we're going to look at the Java coding standards as part of our Introduction to Java Programming class for the FRC. I've mentioned Java coding standards many times during the previous modules, but I haven't really talked about them collectively. I've just introduced individual coding standards. So coding standards are customs or conventions that programmers have learned to follow. They're not requirements by the language. They're not going to generate any error messages if you don't follow them. What they accomplish is it makes your code easier to read. These have all been learned through the School of Hard Knocks by programmers that have come before you. So it's a good idea to at least pay attention to them and be aware of them. So what's the first coding convention that we follow? It has to do with package naming convention. Customarily, we use the reverse internet domain name in our package naming convention. Another thing we use is only lowercase letters in the package. If you happen to have an internet domain name that has hyphens, we replace those with underscores in the package name. And we prefix with underscores if an element in a package name starts with a digit or a Java reserved word to avoid confusion. This is a big one, identifiers. When people are reading code, you don't know how they're going to be accessing it. They could be looking at it on a 4K monitor that's 43 inches across. They could be looking at it on a 19-inch monitor. They could be looking at it on a smartphone, or they could be looking at your code on a tablet. So what we want to do is use visually distinct identifiers to reduce the chance of misreading. So I've got some examples here. The first one's pretty obvious. On the left, I have a 0. On the right, I have a capital letter O. They're fairly distinct in the font that I chose for PowerPoint. But in the font chosen by the integrated development environment, by the IDE, they may look pretty similar. Another one, the next one, I have the number 1 versus a lowercase l versus a capital I. Even with the font that I've chosen, I'm hard-pressed to distinguish between the lowercase l and the capital I. The third one's a little easier, 2 versus z and 5 versus s. On this font, they stand out pretty clearly, but they don't always. 8 versus b, this is one that's caught me in the past, so this is one you should definitely be very careful about. Lowercase n versus a lowercase h. They look fairly distinct here, but I have seen fonts where they look remarkably similar. And this last one, rn versus a lowercase m, I have definitely seen trip people up. So when you see identifiers like this, at least be very careful. In a perfect world, you would avoid using some of these identifiers and use an alternate form. So what do I mean by an alternate form? Let's look at the left-hand example. I have 2 variables that are storing the front of a boat and the rear of a boat. For the confusing example, I've used stem and stern. The only distinction between them is the lowercase m versus a lowercase rn. So if you back up from 20 feet away and you're looking at this on a projector, you may not be able to see the difference. So it's a lot better to just use different words altogether. Use bow and stern instead of stem and stern. Numeric literals. This is one where trying to be clever can get you into trouble. So don't use leading zeros to align numeric literals. A numeric literal is literally a number in your .java file. So I'm initializing 3 elements of an array, the first, second, and third element of an array, with the values 2718, 4435, and what's the third value? It looks like 42. But it actually isn't. In Java, if you have a numeric literal prefixed with a 0, that means you're intending for it to be octal. And in octal, the octal number 42 is actually decimal 34. So even though when you read this code, you think you're initializing it with 2718, 4435, and 42, you're actually not. You're initializing that third variable with a number 34, decimal number, base 10 number 34. So when typing numeric literals, use a case that doesn't cause confusion. What do I mean by that? In Java, numeric literals can have a suffix, which is a letter, and the letter instructs the compiler what size or what type the literal is. So I look at this first example on the bottom left. Size equals 111L. That's a lowercase l, which looks remarkably similar to the number 1. L is short for long. That means that literal is interpreted as a long by the compiler. So what I would do in this case is I would use size equals 111 capital L. Java doesn't care whether the numeric literal is a lowercase or an uppercase. Let's look at another example. Double scale equals 300D. That D can look an awful lot like a 0 in some fonts. So again, I would use a lowercase d. I would say double scale equals 300 lowercase d. In this case, the d means double. It's treated as a double precision floating point number. The class naming convention. So for classes, we always want the name to be a full name. We don't want to use abbreviations. I say that, and then we look at the FRC library, and you've seen part of it in this course, where I've had CAN Jaguar. CAN is an abbreviation for Control Area Network. So again, these are conventions we usually follow, but there's always special cases. But in your code, I would say always use full names. Don't use abbreviations for the name of a class. Classes also always use the Pascal case naming convention. Pascal case means you concatenate words together with no punctuation between them, no underscores, no dashes, no punctuation of any kind. And every word starts with a capital letter. So for example, aerial assist, awesome robot, wimpy arm, PID controller, they all start with a capital letter. Each word of the class name starts with a capital letter. And again, PID is an acronym for proportional, integral, and derivative. So again, we don't always use full names, but we prefer the use of full names over abbreviations or acronyms. If you do have to use an acronym or an abbreviation, treat it as a word and only capitalize the first letter. So you see in the above example, PID controller, the I and the D are lowercase. Class names should always be singular. So if I have a class for the components in a house, I would have window, door, wall, floor. I would not have doors, windows, walls. Likewise, in a class hierarchy for automotive components, I would say wheel, not wheels. A car class might contain a collection of wheel objects. The collection will provide the plurality, not the class name. I've mentioned that interfaces are classes. So with an interface, we oftentimes use the able suffix in Java. For example, serializable, comparable, throwable. With exceptions, we typically use the word exception as a suffix to the name of the class, like null pointer exception or illegal argument exception. Method naming convention. Methods are verbs. They perform actions. They describe the behavior of a class. For the methods in a class, we use Camel Case. Camel Case looks a lot like Pascal Case, but the very first word in the name starts with a lowercase. Then we use uppercase for the start of each subsequent word or abbreviation of acronym. So for example, setSpeed, the word set is all lowercase. Speed, we capitalize the first letter. Deploy ramp, we have lowercase d in deploy and capital R for ramp. Whenever we call a static method, we always want to use the class name dot the static method. Even if the static method is in the same class, the compiler does not require that. The compiler will look in the current class if you do not provide a class name. However, it's easier to read if you see class name dot static method name. Another one I haven't gone over much yet are annotations. Always use the @override annotation when you're overriding a method. So for example, in the sample robot class in the FRC library, there's a method operator control that you're required to override that actually performs the behavior of the robot when we're in the teleop mode of operation during a competition.
I would put an @override annotation at the beginning of the method declaration.
That way, if I misspelled operator control, it would throw an error right then and there, as opposed to just implementing the class that's in the built-in sample robot base class and not running my code at all. Getters and setters. Any method that sets an attribute is known as a setter. So we always name the method set and the name of the attribute with a single parameter for the new value. Any method that gets the value of an attribute is known as a getter. It takes no parameters and it always returns the same type as the attribute. There's a special case, however, when we have a method that returns a Boolean. If a method returns Boolean, we typically name it is followed by the name of the attribute. So for example, if I have a class with an attribute on that is of type Boolean, its getter would be isOn as opposed to getOn. So here's an example of a complete class that has some getters and setters. So right at the top, we're declaring the class arm, and it has two private attributes, up and setPoint. Up is a Boolean, setPoint is a double. So my getter for the up attribute is up returns a Boolean, and the class body contains nothing but a single return statement, return up. The setter for the setPoint attribute is called setPoint, and it takes a single parameter of type double. The type has to match the type of the attribute that we're setting. And the name of that parameter is used in an assignment. We assign the attribute setPoint the value newVal. And here's an example of a getter for a double type. Since the setPoint attribute is of type double, we're going to use the naming convention get. So get setPoint will get me the value of the setPoint attribute, and it returns a single double setPoint. Attribute naming convention. This one I cannot emphasize enough. They have to simultaneously be short, yet still be meaningful. That's contradictory. You can't be both, but I will assert to you that if you work at it, you can come up with short and still meaningful names. What you don't want to do is just name every attribute one letter. You don't want to have a class with an attribute A, B, C, and D. So one-letter variables are reserved for temporary or throwaway variables. You've seen them throughout this entire class in for loops. The iterator I use in a for loop is often called I. In fact, I is an abbreviation for iterator. We use Camel Case for attributes just like we do for methods. And as with methods, we try to minimize the use of abbreviations and acronyms. Don't use punctuation in your attributes. No hyphens, no underscores, nothing like that. Digits can be okay. We tend to hesitate to use them. They're not forbidden, but we do tend to hesitate. For example, if you have an attribute that's there for a challenge in the year 2016, you might have an attribute called challenge 2016 instead of spelling out 2016. But in general, you don't want to have digits in your attribute names. Constants are a special case of attributes. For static final constants, we use upper snake case. So upper snake case means all of the words in the attribute's name are capitalized, and the words are separated with underscores. So for example, I have left motor PID, IP address. So we're using underscores to separate the words rather than capitalization. Remember when I talked about enums, all of the values in an enum are constant. Not only are they static and final, they're also singletons. So we're going to use the snake case with those as well. Use constants to make the code easier to understand. There's no need to use a constant when the intent is obvious or mathematically cannot change. So here I've got an example method. My method is sphere volume, and it takes a radius parameter, which is of type double. It's going to return 4 divided by 3 times pi times the cube of the radius. So the 4/3 pi times radius cubed is a mathematical formula. It's not going to change. There's no need to replace 4.0 with a constant and 3.0 with a constant, because those are the definition of the mathematical equation. Pi, on the other hand, because it's so ridiculously big, has been replaced with a constant, and that's already given to you in the math class. So we're going to use the pi member of math, and pi is in all caps, so we know it is a constant. And as I mentioned before, when we're invoking a static method, we always want to use the class.methodName naming convention. So I know that I'm invoking the pal member of math, but I also know that it is a static method because of the way it's invoked. So that's just a little hint that tells you how this class works. So I know I've mentioned this when we were talking about flow control statements. Always wrap conditional and loop statements in a block using open and close curly brace, even if there's only a single statement inside the block. Another one, I'll highlight this in bold, never cut and paste code. That's probably one of the single biggest introducers of errors into code. If you're writing code and you find that you need to use some code that you've already written, that should make you stop and evaluate, shouldn't this be a method? If it's going to be used in more than one place, it probably ought to be a method. While we're talking about methods, methods should always fit on a screen. On most of the monitors with normal font sizes, that's probably about 15 or 20 lines of code. If you find you have a method that's more than about 15 or 20 lines of code, it should really be broken up into submethods. Similarly, some of the Java development environments do not automatically wrap lines. So if you find that you have a line more than about 70 characters long, you probably want to put line breaks in yourself, because the IDE is not necessarily going to wrap the line in a way you would like. So you might as well get in the habit of wrapping the lines yourself by putting in line breaks where it's appropriate. So variable declarations. I showed you this way back at the beginning of this class. Only define one variable or attribute per line, and declare each attribute with its own comment. Everything should have a comment. This green text out here that follows the / is a comment, and this particular form of a comment treats everything from the / until the end of the current line as a comment. So if we look at this, I'm declaring two variables on the same line. What are those variables going to have when they're initialized? At first glance, when you look at it, you'd think, oh, I and j are both initialized to 10. But that's not the case. I'm initializing the variable I, and in Java, all variables are initialized to 0 unless explicitly initialized to something else. And I'm initializing the variable j to 10. So I is 0 and j is 10. But that's not immediately obvious. So I wouldn't do that. I would say int I semicolon, and then on the next line, int j equals 10. Or ideally, on the first line, int I equals 0 semicolon, and then int j equals 10 semicolon. Then there's no ambiguity. You know exactly what's going on. So that comes to the next point. Always initialize variables when declared. Java does declare them for you. Numeric variables are initialized to 0, pointers are initialized to null. But it's a good idea to get in the habit of initializing variables when you declare them. Not every language initializes variables like Java does. So as you advance in your programming career, you might find yourself using languages that do not initialize variables, like C or C++. So it's a good idea just to be in the habit. It doesn't hurt. It doesn't make the code run slower. The compiler will optimize out any excess initializations. Do not put any space between the method name and the open parentheses. Remember, every method has to be followed by parentheses. That's how Java knows the identifier is the name of a method and not a attribute or a local variable. But don't put spaces there, because that might make people think it's an attribute and the space separating the identifier from the parentheses are part of the order of operations control parentheses. This last one is really important. Don't make non-static class attributes public. I'd pretty much say that, period. If you have a final static, then it's okay and in fact preferable to make it public, because final means it'll never change and static means there's only one instance that all classes share, so you can go ahead and make that public. Although when you do that, you've got to ask yourself, is this one of a number of possible values? If it is, maybe you want to use an enum instead of just a static, a public final static attribute. Indentation. Always align statements within a block, and every block should be indented. In Java, we tend to use 4 spaces as an indent for each block. This is probably the most important. Not every library of code follows the same indentation scheme. What you want to do is be consistent within a library. So if you're working on a library that was given to you or you've downloaded, you want to follow the conventions that have been followed by the creator of that library. That's probably the single most important thing. And I just want to make one more observation. In this day and age, you're going to be using an integrated development environment, probably Eclipse, possibly NetBeans. Regardless of which IDE you use, it will do the alignment for you. You can select a block of code, and usually on most IDEs, Control-I will re-indent that block of code. And if you look at the properties for your IDE, you have a lot of control over how many spaces it uses for indentation, whether you use tabs or spaces for indentation, whether your open curly braces are on a new line or on the same line. So you have a lot of control over this, so there's really no excuse not to be consistent, because the IDE does it for you. And lastly, don't nest too many blocks. If you have more than about 5 nested blocks, you should really refactor your code into separate methods. Refactoring is a fancy way of saying rewrite your code. In Java, the class itself is one Java block. Then the method you're working on is another Java block. If you then have a for loop, and inside the for loop you have an if statement or a switch statement, you're already up to 4 nested blocks without actually doing anything exotic. So it's probably okay in a rare case to have 6 or possibly 7 nested blocks if they're very short and your entire method is still no more than 15 lines. But if you find yourself having lengthy blocks of code or more than 5 nested blocks of code, you should really stop and rethink. Am I doing this the right way? Or are these blocks really the method bodies of nested methods? Should they be converted into methods that you invoke in your code rather than just blocks sprinkled throughout your methods? So that's all of the information I have for the coding standards. So make sure you bookmark this and come back to it again and again and again, because this is important and this will make your code much easier to read. Thanks for watching.